appears when multiple variables are directly proportional to each other. It is where one of the variables is dependent on the rest of the variables, which are called independent variables. The significance of knowing this kind of variation is to be able to determine how quantities have uniform rate of change. Through the process of determining, it allows us to picture a quantity's behavior on how it affects the change of other quantities. For an instance, your electricity bill varies directly to the amount of time charging your phone or electronic devices and the voltage it consumed. In this real-life situation, your electricity bill depends on the amount of time you charge up your electronic device and the utilized voltage. If you minimize charging electronic devices, it also lessens the voltage consumed, which could lead to have smaller amount to pay for your electricity bill. Joint variation is closely related to the topics under the branch of algebra, specifically in linear equations. Both topics involve operations, coefficients, constants, variables, and theories. In terms of relation with constant in joint variation, it is needed to solve for the missing values. A complete set of variables with their values is given at first to solve for the constant, through the method of canceling terms to isolate the constant of variation. Once the constant is solved, the missing values are now to be figured out. As for a linear equation, coefficients are needed to be cancelled out to isolate the variables. Isolating variables lead to figuring out the missing values in a linear equation. Calculus of variations belong to the field of mathematical analysis that utilize variations, which are changes in functions and functionals that could be small or big, to find the maxima and minima of functionals. Many problems in this circumstance are easy to specify. However, their solutions say otherwise. Joint variation is one of the topics under calculus of variation. It is the term used where y as a dependent variable is directly proportional to independent variables that could be denoted as x and z. In short, when one quantity increases or decreases, it affects other quantities to change proportionally, since all quantities involved in an equation are directly proportional to each other. Understanding the concept of joint variation ought to be helpful to majority owing to the fact that it is involved in our daily lives. Additionally, understanding the topic furthermore will give realizations how it is related to real-life situations. It is essential for solving mathematical equations in various fields of science, engineering, and mathematics. It allows one to understand the change of quantities and how it affects one another. This topic explains the huge importance of its main concept, especially how it relates to any aspect of situations in our lives. This will teach majority how to solve mathematical equations related to joint variation using its key formula. The term variation is used to define the relation between quantities, where one could be directly or inversely proportional to other quantities contained in an equation. Joint variation is a type of variation that occurs when a quantity varies directly as the product of two or more quantities. If we let x, y, and z denote as three quantities, the statements will be y varies directly as the product of x and z, y varies jointly as x and z, and y is directly proportional to the product of x and z. And if written as an equation, y equals kxz, where y is the dependent variable and x and z as the independent variables, and k as the constant of variation, and it is always in equivalent to 0. It is understood that joint variation is one of the variations because the relationship between quantities is present, and that is being proportional to each other, whereas all the quantities have uniform rate of change. Briefly, if one quantity changes, either it increases or decreases. The other quantities in an equation will change proportionally since one depends on the other. Calculus of variation is said to begin with Newton's minimal resistance problem in 1687, followed by the Brachistochrone curve problem proposed by Johann Bernoulli. It became a source of fascination to Jacob Bernoulli, a physicist and a mathematician who is eager to expand the theory. However, it was first elaborated by Leonhard Euler with a mathematical analysis. Lagrange was influenced by Jacob Bernoulli, which made him publish his first mathematical work. His work contains binomial theorem and successive derivatives of the product of functions. It impressed Euler, especially that Lagrange was 19 years old by that time. Since then, Lagrange contributed numerous mathematical theories as well as other well-known mathematicians.
I have an example of joint variation, where y varies jointly with x and z. If y is equals to 36, when x is equals to 2, and z is equals to 3. Find y when x is equals to 4 and z is equals to 6. To solve this problem, let us first identify the relation between quantities in the statement. It's stated above that y varies jointly with x and z. Therefore, they have joint relationship. Now that we have identified the relation between quantities involved, let us use the general formula of joint variation, y equals kxz, by substituting the given values of each variable. 36 equals k2 multiplied by 3. It is understood that we must solve for the k, constant of variation. Since it has no given value, we can figure it out by multiplying 2 and 3. 36 equals k6. To completely isolate the constant, we use the cancellation method on both sides of the equation. 36 over 6 equals k times 6 over 6. Become 36 over 6 equals k. The final answer must be in its simplified form. Since 36 over 6 can still be simplified, we must have it in its simplest form. Dividend rather by dividing the numerator by its denominator. Therefore, our constant of variation is k equals 6, where our equation of variation is y equals 6xz. Now that we have solved for the constant of variation, let us move forward with the second set of variables, where we find y when x is equals to 4 and z is equals to 6. We must substitute the given value of the variables to directly figure out missing value of y. Y equals 6 times 4 times 6. After substituting the given values, we can solve for the value of y by multiplying all the values contained in the equation. Therefore, y is equals to 144.
Zenitsu wants to pay for Inosuke, Tanjiro, Gyu's, and Nezuko's bus fare. The bus fare is directly proportional to the number of passengers and the distance traveled. If the bus fare costs 30 pesos for each person and per kilometers, how much would Zenitsu pay in total if they would travel for 10 kilometers? First, let's identify the variables and their values. Let's write B for bus fare, N for the number of passengers, and D for the distance traveled. So, based on the statement, The bus fare is 30 pesos each. And for the number of passengers is 2 and 5 for all of them in total. And for the distance is 1 kilometer but 10 kilometers for the ones they will travel. To find the bus fare amount, we need to find the constant first to determine it all. The solution we will be using is B equals K, N, and T. Let's try the cancellation method. Since they are the same, you should cancel the both of them. As for 2 and these, we will be canceling the rest of them too. 1 and 15. Since 1 multiplied by 1 is, since 1 multiplied by 1 is still 1, our final answer should be K equals 15. That's our constant. I'll write it here. K equals 15. Since we found our constant, now let's solve for the bus fare. You will be using the same solution, by the way. E equals 15 and this is the equation of the variation. So now let's take the values. B is the one we need to find. So 15 parenthesis 5 and parenthesis 10. All of them multiplied is equals to 750 pesos. So there we have it. This is the amount that Zenitsu will be paying for all of them. Also the bus fare total.
First and foremost, we must identify the relationship between variables involved in the problem. It states that the amount of money they earn is proportional to the number of cars they wash and the amount of time they spend. After identifying, let us combine the variables to an equation wherein M equals K C T. Then, we identify the values of the variables where the first set are M is 120, C is 8, T is 3, and the second set finds for M when C is 12 and T is 6. Next step for this is to calculate for the constant for us to solve the missing value. 100 equals K 8, 3. Multiply these two numbers which is equal to 24. Divide both sides with 24. Cancel, cancel. Left with 120 over 24 equals K. Divide this number and have 5 for constant. At last, we now have our constant. Next step we do is to solve for the missing value of M in the second set. M equals 5, 12, 6. Multiply these three numbers which is equal to 360. So $360 will be the total amount of money earned by Rafael, Zane, and Xavier if they wash 12 cars for 6 hours.
Now in this example, A varies jointly to W and L. So we would write that as this. A equals K W and L. This is our equation. And we need to find this, the missing value. To find the missing value, we first need to find K. Yes. How do we find K? We will use these first numbers to find K. So we'll find K. A equals 20 And since we don't know what k is, we just put k. This is 4. See, w. So we put 4. And then we put 5. Now, 4 times 5 is 20. So we write that down. And our goal here is to isolate this guy. So we will divide this by 20 by itself. So it will be cancelled out. And we also divide it here because we divide it by both sides. Then this will cancel out, this will become 1 because 20 divided by 20 is 1. Now this is k. That is our constant of the variation. Now to make that here, this is constant of variation. Now we will now find the missing value using k, which is 1. Now we plug in the next numbers here, which is, we don't know what k a is, so we put a, and k is 1. Now we have the equation of the variation. This is 1, w, and l. Now this is the equation of the variation. This will help us find the missing value of a here. So since we do not know what is a, we just put a, and k is 1. And since we will use this, we will now put 12 in w and 15 in l. Now 1 times 12 is 12. And then we write 15. Then 12 times 15 is, we're gonna times it. 2 times 5, 10. 2 times 1 is 2 plus 3, because this 1 times 5, 5. 1 times 1, 1. And we add this, which is 180. This is this. And our a is 180. That is our missing value. The missing value is 180.
The significance of joint variation in the broader context of mathematics is to gain knowledge regarding on how to solve for the constant of variation, equation of the variation, and the missing values of variables contained in an equation under joint variation. This benefits students as well as the professionals in related fields to know the solution of a joint variation problem they will soon encounter. Joint variation can be used in various aspects of life. For an instance, you want to know how many volunteers you need to finish pasting your posters for 3 hours. This topic enables students to enhance their analytical skills in context of mathematics to rapidly reckon such situations. It ought to be helpful in times when emergency occurs. Having enough background knowledge allows you to swiftly respond with a solution to the problem. In terms of one being most likely to foresee their earnings in the future, this kind of variation is for it.